In this video, I'm going to add two vectors that are not at right angles to each other. Now, when they are at right angles, adding the vectors is pretty easy because we can do the Pythagorean theorem. Now, you can see with these two vectors, I have vector A has a magnitude of 10 meters. It makes an angle of 60 degrees with the positive x-axis. Vector B has a magnitude of 8 meters, and it makes an angle of 45 degrees with the negative x-axis. If I were to draw those tip to tail, I don't get a right triangle. So Pythagorean theorem doesn't work so well. So what I have to do is break these vectors into components. But before I do, I'm going to draw them tip to tail just to get an idea of what the resulting vectors should look like. And I'm going to do this just kind of freehand. So I'm going to redraw my axes here. Here's vector A, something like that. And here's vector B, something like this. Okay, so we can see that my resulting vector, and again, this is just a sketch, so who knows for sure. Points almost straight up, and it has a length of something like this. All right, so we know that the resulting vector should look something like this vector R that I drew here. Now, let's do it mathematically and see how close we come to that. So the first thing I'm going to do is I'm going to break these vectors into components. Now, before I break them into components, actually, I want to write these vectors out using the angles. Now, I'm always going to measure my angle from the positive x-axis. So vector A has a magnitude of 10 meters and has an angle of 60 degrees. Now, for vector B, I'm not going to use this 45-degree angle. I am going to measure my angle from the positive x-axis. So I'm going to use 135 degrees for vector B. So vector B has a magnitude of 8 meters, and it makes an angle of 135 degrees with the positive x-axis. All right, so we know that the x component of vector A is going to be 10 meters cosine of 60. The y component is going to be 10 meters sine 60. All right. For the x component, we always use cosine. For the y component, we always use sine. If we're using this angle from the positive x-axis. If we do the same thing for vector B, the x component of vector B is going to be 8 meters cosine 135. The y component of vector B is 8 meters sine 135. Okay, now, this is a nice little shortcut here. Now, if we think about this, vector A, both components, x and y, are positive. For vector B, the y component's positive, the x component is negative. We don't have to worry about that because by using this angle, the 135, this is going to come out negative. All right, the cosine of 135 has a negative result. All right, so now let's simplify this. So A sub x, the x component of A, is going to be 10 meters times the cosine of 60. Everybody knows that the cosine of 60 is 0.5. A sub y is 10 meters times the sine of 60. And everyone knows that the sine of 60 is 0.866. All right, b sub x is going to be 8 meters times the cosine of 135. That's going to come out to be about negative 5.66 meters. And for b sub y, it's going to come out to be a positive 5.66 meters. If you don't trust my math, you can use your calculator to double check that. Okay, now we have our components. We know that the x component of the resulting vector is going to be a sub x plus b sub x, which is going to be 5 meters plus a negative 5.66 meters, which I believe is negative 0.66 meters. The y component of the resulting vector is a sub y plus b sub y, which is going to be 8.66 meters plus 5.66 meters, which I believe is 14.32 meters. All right, so let's think about this. If we just think about this quickly, our resulting vector has a very small negative component in the x direction and a larger component in the y direction. So if I were to draw that on the axes, it would, r sub x is this, r sub y is this, okay? That's close to the sketch that I made at the beginning. So that gives us confidence that we have the right answer here, okay? Now, without going through the rest of this, this math, our resulting vector, r, is going to have a magnitude of the square root of negative 0.66 squared plus 14.32 squared, okay? And the angle is going to be the inverse tangent of our y component over our x component. Okay, now, because we have a negative sign here, it's going to take the inverse tangent of a negative number. This may not give you your final answer that you're looking for. So I'm just going to do this right now. I'm going to do the inverse tangent of 14.32 divided by negative 0.66. Okay, now, this is giving me an angle of about negative 87 degrees. Which would be down here somewhere, okay? In reality, the actual angle is 180 degrees from there, all right? So if we add 180 degrees to that, our actual angle is really something like positive 93 degrees, okay? So that's something you have to pay attention to if you're taking the inverse tangent of a negative number. All right, it may not give you the exact angle that you need. You might have to add 180 degrees to it.